Here's the gas laws math tutorial. So here's our gas laws formula. That's a P, not a D. That's pressure. So I put in my pressure. My volume needs to be in liters. If I'm going to use atmospheres for the pressure, I got to use this R with the atmospheres in it. That's the R there. I know there are a bunch of units, but I get really sick of writing them in, so I started cheating, and I'm not putting them in there. The moles, they told me, the moles go in for N. Again, that's R, and the T is the unknown. So this times that, divided by that, gives me temperature. But remember, inside the units for R is Kelvin. So when you solve for temperature, you get Kelvin, and we have to subtract out 273 to get Celsius. If you want to go from Celsius to Kelvin, you have to add 273. So if you want to go backward out of Kelvin, you have to subtract 273. And negative temperature in Celsius is a thing. That's not a contradiction. It's not a logical impossibility. That's fine. We put in all the values, convert this to Kelvin. And this times that divided by that gives me pressure. It will be in atmospheres because I used the R that is for atmospheres. I guess you could have used the one that is for torr. And then you would have gotten torr for pressure. If you're going to use this one, you'll get torr. I use that one, so I get atmospheres. What do I need to change here? I got to change that to Kelvin. And then I'm pretty much set up. This times that divided by that gives me moles of gas. Moles equals N. This one has no real setup. It just tells me everything. This times that divided by that gives me volume. You'll get liters because inside of R is liters. You need to use liters for all these, by the way. What's the temperature? Well, I know pressure and volume. I don't know moles, and I know, of course, R if I'm going to use atmospheres. What I have is a hole in my information here. So what I did is I converted my grams to moles, and the molar mass is going to be 14 plus 111. So 17. That moles number goes in here. This times that divided by that gives me T in Kelvin. What's the pressure? Well, I don't know the pressure. I do know the volume. I know the moles. I don't know the moles. That's why I go over here and convert to moles. Remember that oxygen is diatomic. It's O2. When it's on its own with its own kind, it likes to make pairs. So the molar mass isn't 16. It's double of 16. There are 2 oxygen atoms in there. So the molar mass is 32. Divide gives me moles. I did that so I could put it here for N. If I'm going to put in this, I'm going to get out atmospheres. If you're going to use that R value, you're going to get out atmospheres. By the way, kilopascals is the more super official unit for pressure. In a physics class, they would probably use kilopascals because inside of Pascal is stuff like kilograms and meters and seconds and so forth, which helps you interface with the other units you're using, like joules and meters and watts and so forth. In the chem class, we are sort of kind of cheating by using other pressures because we're probably not going to be dealing with areas and so forth, like square meters and stuff. Physics class might use that instead. What do I know? There's the pressure, there's the temperature, it's already in Kelvin. There's the liters, and I'm going to use this because I'm using atmospheres and solve it. That's the moles. That's it. I'm going to have to convert this to moles so I can put it in for here. And I already know that and that, and that's in Kelvin already. And then we can solve for volume. This is going to have to get 273 added to it to convert it to Kelvin temperature. If they're going to give me torr, I need to use 62.36. Look at the top of the front page. And there's my liters. I'm going to add 273 to that here, over here. And then solve for N. But the question is, how many grams do I have? So I've solved for N and it's moles, but it's moles of SO2. And the question was grams. So I need to convert the moles that I found to grams of SO2 by using the molar mass here. Now, the question here is, what's the molar mass? A molar mass is in grams per mole. Well, I know the grams. What I don't have is the moles. So I'm going to go turn this into Kelvin. I'm going to notice I'm using torr. So that puts this as R. And remember that to get from milliliters to liters, the decimal moves left 3 spots. So that's 2.5 liters. When I solve for N, I get 0.0871, it turns out. And remember, I did that because I needed to use grams over moles to get molar mass. And that was a misprint. I don't know. I typed a G over the 2 somehow. I don't know. And it's grams per mole. What's the molar mass? Again, I need grams and moles. What do I have? Grams. What do I need then? I need the moles. I know the atmospheres. I know the liters. Atmospheres means I need to use this R, convert this to Kelvin by adding 273. This times this divided by that is moles, and put that under the grams so that when I divide, I get grams per mole. 2 questions. How many moles do I get? And then how many grams is that? So moles is clearly the unknown. They're giving me torr, which means I got to use the torr version of R constant. Add 273 to that to get Kelvin. 31 liters is given. This times this divided by that gives me N, and that's moles. If it's N2, then the molar mass is 14 plus 14 is 28, and convert to grams of N2.